Hello, my name is Ian Watson, and I'm a Director Emeritus of the American Membrane Technology Association, or AMTA. The interview you're about to see is the 21st series of what we call Chats with the Pioneers. AMTA is a technical association founded on the advocacy of the use of membrane technology for water treatment, from wastewater reclamation to seawater desalination. The heart of this technology is the membrane itself. About 2.5 years ago, our board of directors decided that to preserve the history of membrane and membrane system development, the association should make an effort to record these chats of those responsible for launching what is now a technology that is in common use around the world. AMTA's intent is to make this series available on our website so that new generations of engineers can learn some of the lessons that we all learned in the early days of this technology and apply it to current modern day conditions. With me today, I have 3 members, employees of the Bureau of Reclamation. To my immediate right is Wolfgang Sattler, also known as Fritz.
Exactly.
And we will call him Fritz. In the middle is Chuck Moody, who I've known for a number of years. And to his right is Larry Haugseth, who I've just met today, as I've just met Fritz today for the very first time. I'd like you, Fritz, if you would, to give us a little bit of your background, education, and how you arrived at the Bureau of Reclamation.
I came from Germany, age 17, 1954, on April the 2nd. And I moved to West Tennessee, went back to high school, and had a year and a quarter of high school. I hadn't been to school in 4 years in Germany. You know, I had served an apprenticeship. So I did a year and a quarter of high school, and at graduation time, they recommended me for a scholarship at the University of Tennessee. And I got it, and I wound up getting a mechanical engineering degree in Knoxville at the University of Tennessee. And the Bureau of Reclamation came to interview, and so I got a job in the Denver office. And that was in January of '62 that I actually came to Colorado for the first time. And typical junior engineer, we went to training out in the field office. I went to Trinity Dam for 3 months, and they called it rotation engineering, a 1-year training program for junior engineers. And then after that, they put me on a drawing table, and we designed water supply systems and pumping plant discharge lines, penstocks for high pressure turbines, and did the regular grunt work that was being done by that particular group. About 10 years later, in the early 70s, I became in the salinity control project, and I actually participated in the cost-benefit analysis. You know, what's the benefit of desalting? And at that time, it was very overwhelming. You know, the salinity of the Los Angeles area water supply that was using the Colorado River water was close to 500, which was close to the cutoff. And the water heater life, just on the water heater life, was 3.5 to 4 years in the Los Angeles area with that high salinity, where we projected that you could get 8 years out of a typical water heater if we could reduce the salinity to 250 parts per million instead of it had spiked up to 550 parts per million. And so anyway, I got involved, and they had like a 3 or 4 to 1 benefit to cost ratio. And so desalting was in. So that was my early involvement. I got to calculate some costs of mechanical equipment, in the water supply chain for the city of Los Angeles. And then for several years there was nothing, and then I'm guessing these dates I'm not sure of, but I then became involved in doing feasibility estimates for the Yuma desalting plant. And we did some early stage feasibility and then some final estimates, and that lasted for several years. And then my first, I had always involvement with mechanical equipment for the desalting equipment. I had very little to do with the membranes, but a field trip around 74, 75 to hydronautics comes to mind. They wined and dined us big time, and we had a wonderful, wonderful plant trip showing, how they were rolling the membranes and doing all those things. And so that was I was just past the stage of junior engineer. As a junior engineer, you don't get to travel. All of a sudden, I was in the travel circuit, and started making trips to Yuma. I got involved in all kinds of things, like the recalcining facility. I'd go to Michigan to look at recalcining facilities connected with paper plants in Michigan. And so anyway, we did a lot of studies of Florida, small membrane desalting plants. There was a few in the Caribbean. And so we worked those things up, and the good points and the bad points. And the big decision that came along the way then was what's going to be our main piping material. And what we had found that people using stainless steel piping, and you shut the desalting train down, you would get terrible pitting, and you could perforate this 304L, which was the most likely tubing material, in several weeks, just from leaving the salt water in the tubing. So we were trying to come up with a way to properly drain it. And obviously fiberglass piping would have been the most, but the pressure was too high on some. We could have some fiberglass in the discharge circuit, but not in the intake circuit, where we were pushing it 400 pounds per square inch on average. So anyway, not only that, the pipe selection, the conductivity sensors had to be housed in a way to keep them from corroding and gumming up. And then we were working on the control systems. In those days, we were using power plant methodology, and everything was hardwired. It was just, there was some computer programs coming into play around the mid-70s, but we decided to do everything without, and we realized that 10, 20 years later, it would be done with software, but we did everything hardwired. We had to design the control panels for the desalting units, and so on and so forth. So I had lots of wonderful trips, lots of learning, and when it became to the procurement stage, I went to visit the main valve manufacturers that were providing us with the 600-pound rated butterfly valves and so on. And so we had an inspection going on. Did they build these valves to our specifications? And same thing with rolling the aluminum bronze piping. I got to go to AMCO in Wisconsin to witness, some of their pipe fabrication and, some welding samples being done and all of those things. So all of these things entered into my thing, and looking back on it, I think I had a close involvement in specifying over $400 million worth of equipment. The feed silos, there were certain non-mechanical items that the civil engineers handled, like the big concrete thickeners and those things. But a lot of that out in the yard equipment was, not necessarily designed. We used standard equipment, but we try to size it and fit it to our application. Right. And so one of the interesting things is on these big chemical silos, they had vibrators on the bottom. And, everybody has trouble with these chemical feed coming out of the big silo. You get, those are, we worked up special cycles of vibration and everything else to have the top of the line. And the sad thing is that, we never really got rolling. The problem at the end was that all of the farmers, they were offered, well, if you give up your water rights, we'll pay you $200 an acre foot, or some amount that the farmers and ranchers just gave up growing and took the money instead. And that, for that reason, the Yuma desalting plant never went. And full bore, we've had several test runs, but anyway, it was a great experience. I loved every minute of it, and, I visited after I retired Ed Lohman in Yuma and Trumpeter in Las Vegas. They were both poker buddies of mine. And when I was in Yuma for a 6-month assignment, I actually had a regular poker game there, where Ed Lohman came all the time. Yeah. And so anyway, it was a great career. I loved it, and
And when did you retire from the Bureau?
I retired in 93.
93.
I've been retired for 20 years.
Good.
And I like that too.
Good. Well, thank you, Fritz. Chuck, how about you?
Well, I came to the Bureau. First, I grew up on a farm in Yuma, Arizona. And after 12 years farming, the farm went under. My dad got a job with the Bureau. My granddad also had been a civil engineer with the Bureau. So I went to the University of Arizona, got a degree in physics, worked with John Kessler, professor of physics there, on our first forward osmosis experiments. And so then I went in the Peace Corps and came back and worked on forward osmosis some more, and published my thesis in 1977. And my dad told me about this desalting plant going in Yuma. So I interviewed Frank Leitz and got the job. I had a pretty strong background in understanding how membranes worked, at least I thought I did. And that's how I came to the Bureau.
Good. And you worked on the Yuma project, and you've worked on other things at the Bureau as well.
Well, it's interesting, when you come to the Bureau, they have the jobs in Denver, and there are Yuma desalting test facilities in Yuma. Well, sometimes it's difficult to find people in Denver to go to Yuma, like in the summertime. But since I grew up there, it was like a briar patch situation from the Bear Rabbit. I was born and raised there. So when they asked, they're looking for candidates to go to Yuma to work, for several months at a time. I raised my hand. So I served as technical program monitor for the humidity salting test facility from, I think, 81 to 82. A lot of good work down there at the test facility.
Yeah, yeah. And you've been involved, and you're still working for the Bureau.
Yeah, I still work for the Bureau.
And you're still involved in membrane technology?
Right, well, after the desalt, yeah, the whole time.
Yeah.
I looked at some other, selenate removal worked pretty well, formaldehyde oxidation worked pretty well. In fact, in '91, we started the plant. Before we started the plant, we had trouble with cellulose acetate membranes losing their rejection pretty quickly. We have a 1 million gallon per day pilot system 1. And it turns out when you used 1.5 milligram per liter of free chlorine, it was, the membranes were going bad within a year. So with John Franklin and Ton Amerlin, we had a piece of pilot equipment I designed, and we figured out it was the ferrous iron in the water. Not ferric, it had to be ferrous iron. So it's rusting iron from the stainless steel that Fritz is talking about.
Mm-hmm.
It's rusting just a little bit, as the first byproduct of iron rusting is green rust, which is the ferrous. And that in combination with hypochlorous acid, that's free chlorine, was causing the membranes to go bad. So that was exciting to figure that out.
Good. Larry, what about you?
University of Illinois, mechanical engineering. Got out of there and short stint in the Army. Got out of there and got a job here in Denver with Denver Fire Clay Company, and from there worked there 2 years, and then went to Australia, worked for a year major furnace and combustion engineering. Came back, talked to some friends that were working at the Bureau. They said, why don't you try getting a job at the Bureau? I did. My degree from University of Illinois was mechanical engineering. Next thing I knew, I was in the mechanical branch with Fritz, and his boss was Fritz too. And 10 years in the mechanical branch, I decided around 1970 that I needed a change. I signed on with the water conservation group in research, and which is a building just east of Building 67 there at the Federal Center. Found out that the job that they wanted me for was to go to Roswell, New Mexico, and run the membrane plant there. And Roswell, of course, everybody knows this was a project of Office of Saline Water, and Office of Saline Water had 4 other research facilities. I think is Freeport, Texas, and Webster, was it South Dakota, and then Wrightsville Beach and Point Loma. My job was to go to Roswell and test the membranes there, and to compare that with I think it was the General Electric vapor compression plant that was located there. And when I got down there, I found that they had an electrodialysis unit set up, Ionics electrodialysis, and they had a Havens large diameter membrane unit, and they had a plate and frame they had set up, and spiral wound. And so we got all this equipment running, had a couple technicians there, ran it for I think about a year and a half, sent reports to Mel Lou, who was working for Chanabasapa. And actually everything seemed to work quite well. The only treatment we had, the water down there in Roswell was it had a lot of magnesium sulfate, which is kind of a laxative, and 1,200 part per million, I think it was. But the only treatment we gave all those membrane plants was hexametaphosphate and sulfuric acid, which and so we kept the pH down to, what was it we kept the pH down to, Chuck? Was that
5.5 or something.
5.5,
Yeah.
something like that,
Something like
yeah.
that.
And then the hexametaphosphate.
That was all groundwater.
All groundwater.
Yeah, right.
Things worked actually quite well for a year and a half, although there was a steady deterioration of flux. The hexametaphosphate was designed to prevent scaling, even though we were beyond the saturation limits of scaling compounds, calcium sulfate and others. And then when I first got down there, on the spiral wound unit, it was Universal Oil Company that made the unit, and they were very soft, spongy units. They didn't perform that well, and then they sold out to General Atomic, I think it was, and they came in with a spiral wound membrane that had a nice solid outer shell, and that they worked very much better than those original, I call them mushy, spiral wound unit. Anything to report there? Only thing is that when I was down there, General Electric did start that vapor compression plant at one point. Had a great big motor on it, 150 horsepower or something. It had the step started, dimmed the lights in Roswell when they started this thing up. Didn't really work. It did work. It did dissolve water, but it was an enormous production compared to membranes. And I actually thought the engineers were a little bit afraid of the thing, but the other problem they had with it, the pipes would freeze there, and on that big vapor compression plant, so they're constantly fixing valves and repairing pipes.
Yeah.
Anyway, no, it was fairly successful. I had one story to tell, and that is that we had a convention in Grand Junction, Colorado. And I got over there, and I realized I didn't have my wallet. And I told Chana Basapa, I said, I don't have any money. He said, oh, why don't you come and stay in the motel with me? So I spent the night with Chana in a motel there in Grand Junction, and while we were in the motel, he asked me, he says, of all those units that you were testing down there, which unit do you think has the greatest potential, the greatest future? And I said, well, I like the spiral wound the best. But I've often wondered, did that little conversation have any impact on the overall industry? I don't know to this day. Then I was asked to go to Fort Morgan and test a plate and frame with a salinity. Fort Morgan, Colorado, they have a selenium problem there. Tested that plate and frame, had a big disaster with the first one. Started a waste pump that sucked the membranes off the plate and frame. We had to get a new core for the thing. Found out on that experiment that you must pressurize and hold those membranes down on the plates before you start any other pumps. And so that was interesting. Got sent up to Gillette, Wyoming, and there they had, I think it was an Aerojet General, large diameter, about half-inch diameter tubes, and over there this film would form on the membranes. It almost looked like there's no pre-treatment in any of these places. Pre-treatment came along later with Chuck and the Yuma desalting plant, the lime treatment, and so on. But in Gillette, there's a sulfur-forming bacteria that just completely coated the membranes. It would stop the production almost as soon as you got it started, and the only way to clean it was to high velocity flush, and all this stuff would come out on the floor, look like toilet paper, wet toilet paper. So that was a disaster. I think after a while we learned you got to have pre-treatment to get this water clean before you attempt these membrane processes. Went to Saudi Arabia with Ed Lohman. They sent us over there. By this time, I don't think Office of Saline Water was in the picture. What was the other group that followed? It was
Office of Water Research and Technology.
Yeah, Office of, right.
For a short period of time.
And got over there. Ed was an expert on multi-stage flash distillation, and I was supposed to be an authority on membranes on the west coast of Saudi Arabia. I mean, on the east coast is all distillation, and on the west coast is membranes. We sat through meetings over there. My impression was that we were there to listen, not to say anything. And found out that they were using, they were taking water. This is at Jeddah, Saudi Arabia. They're taking water right out of the Red Sea and adding copper sulfate and running it into their membrane units, seawater units. I think it was 2 or 3 stage. And very successful operation. The only trouble is all this copper sulfate ended up back in the Red Sea, and I thought of that as a really bad thing to be doing. I think I did mention it, but anyway, we ended up urging them to switch to chloramines, but they said they could not and would not do that because they had a successful operation as it was. And when we left there, they're still dumping copper sulfate into the Red Sea, which is one of the finest fish environments in the world. So I wasn't happy with that. Anyway, that. And then I came back and worked with Chuck. Decided that it's pointless to be importing water to the Federal Center, and instead developed a mobile test unit that Chuck has been using, and thanks to Chuck, it has had reasonable success, is the mobile test unit. That's all I have.
We took it to Tucson. When Larry put out the budget to build this trailer, it's a semi-tractor trailer equipped with reverse osmosis and chemical feeds and pre-treatment as filters. People were worried about he was using up our budget building this trailer. Then after Larry retired, that was like our biggest selling point. That was our biggest capability, was Larry's trailer. So we took it to Tucson for a couple of years, and then Marana down in Arizona also used it. Very successful, Larry. It's a good idea.
Good idea.
Yeah, that was, you had it at Tucson when they had that problem with their new water treatment plant, didn't you?
Well, they had problem with the water treatment plant. So afterwards, when they're not using the water treatment plant, they refused to take reclamations of water from the Central Arizona project. That's Tucson. But they would consider, if we desalted the water, then it would be the same quality as the groundwater. Tucson has very nice groundwater, very good quality, 200 milligram per liter. In fact, they used to serve it without chlorination, it was so good. So they said if we could produce water as good as the groundwater, the citizens would reconsider. So that was for the pilot test. We're about to desalt Colorado River water.
And when was that, Chuck? You remember?
96 to 2000.
Yeah, they're still having the same conversation down there.
Yeah, well, you can talk a long time before you have to spend a lot of money.
Chuck, when you went to work for the Bureau,
Yeah.
you had done some work in your graduate studies on forward osmosis, which in those days was pretty unusual.
Right. I worked with John Kessler. Our first experiments we did in '71. He had contacted Bob Riley, and Bob Riley had sent us these membranes. And so we tried out fertilizer-driven forward osmosis, which worked really well. That is, the fertilizer, see, in forward osmosis, you don't get pure water from forward osmosis. You get, in the case of fertilizer, a fertilizer-charged irrigation water. But for open field agriculture, after we did the test worked, but you really don't get much, you get only 1% of the water requirement with the fertilizer. So then we switched to human nutrients, in which case it's well matched. Your daily intake of, say, 2,000 kilocalories of food energy can supply several liters of water from seawater and 10 to 20 liters of water from brackish water. So it's a well-matched ratio of food and of nutrient and water requirements. So I did that, and then, so John Kessler, we call him the father of FO. He coined the word FO because he wanted to explicitly distinguish it from reverse osmosis, which is going in reverse. He wanted to say we're going forward. So anyone who uses the word forward osmosis is paying homage to John Kessler. And so
when you got to the Bureau, did you make any effort to get them interested in the work you've been doing in graduate school? Because it would seem to me that would be a good fit with the Bureau's mission.
Well, I didn't. Before I came to the Bureau, we'd proposed to the Navy to develop forward osmosis as sort of a life raft survival kit. Because if you use human nutrients, it works well. If you use alcohol, it works really well. Because you get a solution that's about with glucose and fructose, you'd get about a 10% drink, which is very easy to drink in relation to seawater. No, I didn't try to do the Bureau. I came to the Bureau to learn how to do reverse osmosis better and to work at the human desalting test facility. Because I had to admit I was young and wet behind the ears as far as what really makes a process work or not. I studied the theory and done a few laboratory tests with forward osmosis. So I enjoyed using those theories in describing reverse osmosis. We did, in '99, I did send my, Rob McGinnis at Yale called me up. So I sent him my thesis. And so it's been very satisfying. Yale has developed quite a few people that were working at forward osmosis. Right. And then in 2000, DARPA, Bill Warren, was trying to get Bob Riley to come up with some new ideas. So we proposed forward osmosis. And so beginning in 2000, we had a small business innovative research, they call them SBIR, contract with DARPA. So that was with DARPA for a couple of years. And after that, the Army invested in it, and then the Navy. The main thing about forward osmosis, there's a lot of good applications out there, but the main thing they all need, and I think probably still could have improvement on, is the membrane itself. They need efficient membranes, which means mainly thin membranes that are chemically robust. And they have some cellulose acetate membranes, but they're not that thin and they're not that chemically robust. So Bob was working on developing membranes, has been working on developing membranes, Bob Riley, that can be used in any application. We showed, there's an interesting story, at Bill Warren's urging in DARPA, he had us share how to make these FO bags, hydration bags, where you have a bag, you throw it overboard or put it in a bucket, and then it puffs up. Oh, first you put some powder, like Gatorade type powder in the bag, and then you throw it overboard or in the bucket, and it puffs up after a few hours. So we showed REI, Recreational Equipment Company, and their Mountain Safety Research Branch, how to make the membrane. So we showed them these membranes. Well, then they went and showed HDI how to make it. And so now HDI selling, you can get them at Costco. So there's one time Bob Riley was saying, when we were talking about, you know, when you have overseas, there's this infant formula problem where if you have contaminated water and you use infant formula, the baby gets sick from dysentery and dies. So the idea, if we had these infant formula in these packs that we sent overseas, then you'd have physically disinfected water to hydrate your bags. And so Bob Riley once said he'd like to make these bags and give them away for free. So I said, well, Bob, they're not being given away for free, but you're not making any money. Because HDI is making the bags.
Yeah.
And good for them for doing it.
So let's talk about humor a little bit, because you're all involved in humor. I noticed in the write-up you sent to Doug that you had worked a little bit on not only the piping system, but
Which system?
the piping system.
Yes.
So you elected to go to aluminum bronze, but you also were looking at FRP as it relates to the the membrane pressure vessels themselves.
Yes, exactly.
And I was interested to see that you'd been doing some work on that and had caused the thickness to be increased to make it a 50-year life component as opposed to a 20-year life component. Could you describe a little bit about what you did there?
Well, first of all, in our lab, we try to come up with some basic FRP relationship to pressure and aging. And then, we had pretty good data with vessels going up back 10 years. Some of them actually had been stored in the lab. And so we knew that initially you get typical strength of 14 to 18,000 psi. And then after, it was a steep decline, and slowly would flatten out. And after 10 years, you'd be down to 13,000 psi. And, at 20, 25 years, you were down below half. And so, we included a 1.5 safety factor. And so we had relatively, the hydronautics vessels were probably about half-inch thick, and they were 8-inch diameter.
8.5. 8.5.
8.5. And fluid systems, was close to 2 inches thick, those vessels.
Yeah, it's a larger diameter.
And much larger, or larger diameter. And I think, were they 30 inches?
12 inches.
12.
Oh, 12. Yeah, okay. So, anyway, we decided that you couldn't do it for the main piping. It was just, at that time, the FRP technology hadn't advanced to reinforce it better, or to get higher strength out of it.
Right.
So anyway, we designed for a 50-year life. But with the safety, that was, it could have been interpreted as a 35-year life if you took the safety factor out.
Right. Now, Larry, in some of your early work, you were comment, or when you were telling us about some of your early work, you were commenting on the fact that a lot of the systems that you were looking at Roswell and elsewhere had no pretreatment. Now, it was pretty clear that you were going to need some pretreatment at Yuma on the Welton Mohawk drainage water. Did you work on that at all?
Not too much, other than reviewing industry recommendations. Did a lot of that, and remember we got that big report from who was that report from that said lime treatment was the way to go.
And that's what you eventually was built there. Was lime.
That's what we eventually
lime coagulation
went with.
purification.
But I was in the Denver office just reviewing proposals and industry recommendations here.
One of the reasons to go with this partial lime softening, they call it, because it uses the bicarbonate in the water to perform calcium carbonate with the lime, was the cellulose acetate requires low pH of about 5.5.
Right.
And to bring that down, so the lime softening had the advantage, even though you're adding a chemical, it removed the buffer, the bicarbonate, so that to drop the pH down, you didn't need much acid. So that's, even though you paid for it lime, you saved on acid. And I'd heard that story for a long time, and I thought, oh, I don't know if I really believe that. But when we ran the plant, but sometimes acid prices go up, and then you really notice a difference.
Right.
And so we just had a report done by Siege Tomb Hill and Black and Veatch for our partners in Yuma on a test we had with MWD, Southern Nevada, and Central Arizona Project. And they just looked at the comparison of replacing their lime softening with microfiltration pretreatment. Of course, lime softening is already there, but it turns out the lime softening with polyamide membranes, if it works effectively, is 20 to 25% less than microfiltration would be if we brought in new microfiltration. Of course, that's comparing an existing facility with a replacement. But even now, what are we talking, 30 years later, 40 years later? The lime softening it works very effectively.
Yeah, that's an interesting point, because I can imagine, you know, on a project of that capacity, you would have been bringing sulfuric acid in by the trainload.
Actually, you're right. What you would require a couple hundred milligrams per liter of sulfuric acid, and right now we use maybe 50.
Right.
And the price of acid, I can't think of it right now. It would increase the total cost of the plant by 20% or so, just the acid.
Now, did you ever build the recalcining equipment there?
No, we looked.
You looked at it, right?
It was never
built.
Procured while I was working for the Bureau.
Okay.
And I assume, I mean, it hasn't been needed. They decided that in the small quantities they can buy the quick lime.
Buy lime, yeah, that's right.
The only trouble with the lime is we have these ponds that we fill up with 20% slurry, evaporation ponds, and eventually we cover them up and they become permanent storage ponds. So that's an issue. That's a cost we have to deal with.
When I first moved to Florida, there was a lot of lime softening used for municipal water treatment. And the farmers used to buy the lime, or I guess they didn't buy it, but they came to pick it up, the lime sludge, and they would plow it into their fields.
The calcium carbonate product.
Yeah.
Well, that's the difference between the East Coast and the West Coast. The East Coast, you have acid soils. On the West Coast, we have alkaline high
soils.
pH soils.
Yeah.
So we have less of a market.
Yeah.
And with the transportation cost, probably wouldn't pay to.
Right.
It doesn't appear to pay anyway to transport it very far.
There is one footnote to this pretreatment at Yuma. I ended up running some experiments on using the brine to regenerate ion exchange resins, cationic ion exchange resins, to soften the water. I ran tests, and my tests were followed by Dr. Kakinen's tests on the subject, and I think we both showed that it was feasible. Same as a home water softener where you regenerate, you soften the water using salt. Well, we have all that brine water at Yuma that can, why not use it to soften the incoming water? But apparently this concept has gone nowhere. And what about that, Chuck? Is it?
Well, I think it's a very exciting process. It's almost like magic, where you use the same composition of water that comes out the reject as a salt replacement. And the way that works is in the ion exchange kinetics, at different ionic strengths, the different components favor. So at high concentration, it favors the sodium form on ion exchange, and at low concentration, it favors the divalent form. Well, as a matter of fact, Larry, Water Reuse Foundation has just funded a project to evaluate that, and with Carollo engineers in Phoenix.
Oh, good.
We're evaluating to increase the recovery at the Scottsdale plant, for example, even higher. They're looking at the RO reject and then taking it through an ion exchange softener and then going through an electrodialysis unit. And my contribution, I think my probably major contribution was forwarding them the papers that John Cochran had written in reclamation in the 1980s. Because I think it's an exciting process that you get softening with no or little sodium chloride usage.
Yeah.
No, because this sludge pond thing is no fun.
No. No.
You said that you encourage storytelling. An adventure I had with Larry Haugseth in the early 60s. We were junior engineers, and Bob Stelzer, Larry Haugseth, and I decided to go cross-country skiing. And the plan was to go to Berthoud Pass, take the chairlift up to the top, and then go down the ridge for 7 miles, and then ski down into Winter Park. That was the plan. Well, we didn't get started at 6 in the morning or something. We got started, left Denver probably at 9:30, got up there at 10:30. By the time we got up there to the top of the chairlift, the weather was changing. And we decided to, just 7 miles down a ridge and then skiing down into a valley, no problem. Well, we went about maybe halfway, 3-4 miles, and it became so that you couldn't see the hand in front of your eyes. It was a blizzard, and so we decided to take a shortcut back down to the highway. And we started going down the hill, and as we were proceeding down there was this huge cornice that we had to cross, and we crossed it. And then this thunderous noise, snowslide. And I skied like a son of a gun to get into the trees. And I looked back, and Bob Stelzer was digging himself out, and Larry was gone. And so, I'm now 400 or 500 feet below him. So I start working back up into the avalanche field. And in the meantime, Stelzer has dug himself out, and he sees this much of a ski pole sticking out of the snow. And by the time I got up there, he had exposed Larry's face. It was under 1 or 2 feet of, how much snow?
Yeah, it's about right.
1 or 2 feet of snow. And I had cross-country skis, and that snow packs almost like igloo ice cubes. And I used the backs of to cut blocks to lift out so that we could free him. Anyway, it took us probably an hour to dig him out. And in the process, I broke my skis.
Yeah, he broke his ski.
So then I went on 1.5 skis back down in the trees, and it was getting dark. This is like in February of 63, is that about right?
I think so, yeah.
And so we spent the night, snow depth is like 12 feet, and we dug a hole 6 feet deep and built a fire in it. And during the night, I couldn't sleep a wink. I'd go and get new firewood. Larry was snoring, Bob Stelzer was snoring, sleeping well. But, you know, we were 20-something guys and tough. Just recently, we had a group of super experienced avalanche people. Five or six of them got killed, right? Up there.
Buddy Werner.
On Loveland Pass. Yeah. And that's just this year, this last season that happened in Colorado. So Larry was lucky, but it was an experience that you never forget.
Well, I have a question. You know, you spent all this time digging him out, and you broke your skis. Did he buy you new skis?
No.
No. In those, I had Army surplus skis.
No wonder they broke.
And you could buy a new set for $15.
No, but
There's some excitement moving to Denver and working for the Bureau, I guess, huh? I didn't even think about that.
We had to participate in this mountain activity, didn't we,
yeah,
Larry?
yeah. But as I was going down, it's sort of like somebody pulling the rug out from underneath you there. And things happened real fast. I saw a bird in front of me fly up, and I said, well, he's okay, but I'm done. Anyway, I decided to stick my pole up in the air as far as I could.
It's a good job you did.
Yeah, that's what, and then I couldn't breathe under there, so I moved my arm out about like this, and I developed a breathing hole. But my biggest worry was that these two guys had got buried too, see, because I didn't know where they were. Luckily, they weren't. So, I mean, it was an experience. Boy, I'll tell you.
No, you all, luckily you all three survived and went back to the Bureau to work. You know, we could probably sit here and talk for quite a while, but unfortunately we're the slaves of time management. And so I'd like you, if you would, first of all, I'd like to thank you for coming and sharing some of your history with us. And so let's go in the opposite direction. Larry, why don't you have a few closing remarks?
Closing remarks. I just think it was an honor for me and a pleasure. I've never regretted. I retired the same time that Fritz did, and so I've been retired almost 20 years too. But I really enjoyed that. It was a very exciting period in my life, and I don't regret it at all. Perhaps I should have stayed on like Chuck did and others and kept going, but I retired.
You can practice your skiing.
I finally got rid of all my skis. I'm just not a good skier.
Chuck? You're still working.
First of all, I'm proud to work at Reclamation. My grandfather worked as a civil engineer in Montana and then down in San Carlos Irrigation Reservation in Arizona as a civil engineer for the Bureau of Reclamation. Then my dad worked as an appraiser for the Bureau, and then I worked. So I'm proud to work at the, it's like wearing a white hat where you like to do good as opposed to tearing things down. We like to build stuff up. I would say one thing I've observed is the Bureau of Reclamation forgets that when you have an irrigation project and you bring in water, irrigation water, you also have to supply a drainage, a discharge. When we didn't do that in the Welton Mohawk, we had to put in the desalting plant, well, a bypass canal and a desalting plant. When we didn't do it in Central Valley, we created Kesterson Reservoir. The Bureau had planned to have a discharge there, but it didn't work out. Anyway, when we didn't have one, it came back to bite us. At Salton Sea, we don't have a discharge. It goes to the Salton Sea, which is eventually becoming more of a challenge to address. And now we have the Central Arizona Project. We brought water in, 1.5 million tons a year of salt, and it's gradually accumulating in Central Arizona. The groundwater is rising, and we don't have a discharge from that. So I think what we fail to learn is when you bring in irrigation water, you got to have a discharge.
Right, right. I know that the Central Arizona project, they're really concerned about that. And they really don't have any place to go with it except the really long canal.
Yeah, well, they have a good place to go. It's downhill to Yuma. And at Yuma, we can desalt it, you can send it to the Salton Sea, or use it to maintain riparian vegetation along
There you
the
go.
Scenic.
That's a.
We call it the Central Arizona Salinity Interceptor, which I proposed in 1995.
Are we going to see it
And
anytime soon?
I'm still pushing it every interview I get.
Good. Well, hopefully somebody who sees this interview on our website will pick it up and run with it. So thanks, Chuck. Fritz, how about you? You've been retired 20 years. Do you wish you'd stayed at Bureau? Or?
We had a RIF, reduction in force. And at that point, I was supervisory mechanical engineer, and 2 of my young guys would have gotten it, or I could go. And I went, but I've never regretted it.
Good.
I started a business selling land, and I'm fully involved in it today.
Good.
And it's, I'm out in the high mountains all the time. We sell land all the way up to 12,000 foot elevation near the New Mexico border. And it's a great way to spend retirement.
Yeah. Well, thank you all for coming. I appreciate it. And that concludes interview number 21.